Hello everyone. In this video we're going to continue on with lesson 10 and we're going to start talking about tests for association when we're looking at two categorical variables. And so we introduced this idea in the last video and we went through comparing percentages and trying to reason through a contingency table, but that's often hard, although that's not a bad idea. It's not a bad thing to do. Okay? But another thing to do, I'm not trying to tell you, side note, I'm not trying to tell you that one is better than the other. Okay, they each serve their own purpose, and they're each good in their own way, in their own certain situation. This is just something different, not necessarily better than what we talked about before. What we can do is perform a hypothesis test to test if there is an association or not. Okay. So, in this hypothesis test, the steps are going to be exactly the same as any other hypothesis test that we do. Okay, so we'll have the exact same 7 or 8 steps, I forget how many we have, in doing this test. As any of the hypothesis tests, either in lesson 8 or lesson 9. Okay, same steps, but of course the calculations are going to be different from what we're used to doing. Okay, and it'll be I guess, a little more weird than moving from p to mu, because of course we have categorical variables. So the biggest difference that we're really going to run into when we try to do this hypothesis test is actually making that test statistic. Because what we did before was basically we made a z-score. So I don't know if I explained that explicitly or not, or if you caught on, but what we were making in that test statistic part is a z-score, which of course you have to remember back to what the heck a z-score is. Okay, but we were making a z-score, and then we knew the distribution of that z-score, and so we could find the probability and move forward. Well, it's not going to work here. Okay, we have to do something that looks fairly similar to a z-score, but is quite different. Okay, so we have to find out how to calculate the test statistic. And the test statistic is our quote-unquote distance from the null hypothesis. Okay, and if that distance is large, then we reject the null hypothesis, and if the distance is not that large, then we fail to reject that null hypothesis. So we have to find out how do we do distance for categorical variables, which I've repeated many times is tough. Okay, easy for quantitative variables, tough for categorical variables, but there are ways, and we will see them in just a second. Okay, the hypotheses that we're going to work with in this test are, again, going to be different than what we're used to working with. Usually we say p equals some number for the null hypothesis, or mu equals some number. But now we're actually writing these out in words. Okay, there are symbols that we could write it out with, but they would be very complicated and is not in the scope of this course. So we're writing them in words. The two competing hypotheses, again, not numbers, are words, and they say that the null hypothesis is that the two variables are independent and have no association. And the alternative hypothesis is that the two variables are dependent or associated in some way. Okay? And so those are the hypotheses that we're working with. And coincidentally, you will write these hypotheses in exactly this way for every test for association of categorical variables. Okay? So there's no choice, nothing on how to write them. These are free points. Just write them like this right here in this slide. Okay. Anyway, so there's the hypotheses. The test statistic that we're actually going to use is this. Okay. And I know this looks really weird at the moment, but I'll explain each step and I'll give you the opportunity to calculate this test statistic, okay, in the homework and on the graded worksheet. Actually, not on the graded worksheet, but in the homework and in many places, okay, and in this your turn that's coming up in just a second. Okay, so there's that statistic. What does it mean? How do we calculate it? Well, okay, so there it is again. It has two parts, the O with a subscript I, and then the E with a subscript I. Okay, you don't even really have to remember the subscript. Okay, that's not really important. You just need to remember the O and the E. Okay, the O is the observed cell count in cell I of the contingency table. So if you think back to the table that I showed before, okay, the observed cell count is literally the count that is in the table, the number that is in that cell. Okay, that's what O sub I is. E sub I is the interesting part, and it's, of course, the harder part or the more challenging part to get. Okay, E is the expected cell count. Okay, so that's the E. And what I mean by expected cell count is it would be what the table would look like if the two variables were actually independent. Okay, and so that's what I mean here when I say exhibits independent. Okay, so it's the expected cell count of a table that would actually exhibit independence, or that is actually independent. Okay. So for instance, if I have, if I have an observed table, so suppose I take measurements, this is an old table, okay, from a while ago when they only coded gender as male and female. So forgive me for that, but they have male and female as gender, and then right and left-handed. There's also no ambidextrous or anything here. Okay, so this is sex and what your dominant hand is. Okay, so that would be the observed table, or the table that you saw, your sample, and 8, 3, 8, and 1 are going to be those O sub i's. Okay, and then you're going to have another table in which we'll find out how to calculate in just a second. Okay, that will have numbers in them in the same sort of positions over here. Okay, this table over here exhibits independence. Okay, or we would say it is an independent table. If we did a test for independence on this table right here, we would get emphatically that we would fail to reject that null hypothesis that they are independent. Okay, so how do we actually calculate that expected table? So there's the observed and expected. Again, we're trying to find out how do we get that table. So how did I calculate the expected table? Here's the formula that we're going to use. So you get the expected cell count, E sub I, by taking the row total of that cell times the column total of that cell divided by the total sample size. So again, what do I mean by that? Let's look at the top left cell in the contingency table. Okay, so I'm looking at this male and right-handed right here. Okay, so the row total is the first thing I'll see. So I'm sorry, that's a column, my bad. So in my slide building here, the row total for this cell here is the total for this row, 11, okay, times the column total, 16, divided by the total sample size. Okay, so the sample size of the entire table. And when you do 11 times 16 divided by 20, you get 8.8. Okay, and so down here is the actual equation there. Okay, 11 times 16 divided by 20 is 8.8, and you can do the same thing for the 4 cells. Okay, so that's how you get that expected table. Now, that's the first step. The second step that's important in this sort of calculation is actually calculating this statistic. Okay, this O minus E squared divided by E. And then this capital, this big thing here is called a sigma, capital sigma. Okay, and it means I'm going to sum over everything here. So what that means in calculating the statistic is I do this calculation, O minus E squared divided by E, for every cell. Okay, so I take 8 minus 8.8 squared divided by 8.8 plus 3 minus 2.2 squared divided by 2.2. So on and so forth for all cells in the table. Okay, and in the end, I'd get out a number. So for this specific example, it's 0.808. All right, so in this your turn, what I want you to do is I have a simple contingency table here, whether or not you're an introvert or an extrovert, okay, whether you're one or the other, and then your political affiliation. And of course, we only have Democrat and Republican, but of course, they're independent and blah, 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 blah. Okay, oversimplified. I want you to find the expected cell counts and calculate the statistic for this. Okay.